Today we're going to build off from our frequency table that we created for a histogram to the cumulative relative frequency table that we're going to use for a cumulative relative frequency graph. A cumulative relative frequency graph uses what we call the percentile, and that's a distribution of the values such that a percent of the observations fall at or below it. So your SAT scores and your ACT scores are often delivered to you not only your numerical score, but what percentile you fall in comparison to other students that took that test. So for instance, we're going to look at the next slide. So in this case, it says Roberto received his ACT score, and that said that he was in the 80th percentile. And so what that means is that 80% of the people that took that test were either equal to or less than Roberto's score. So being in the 80th percentile would be a good thing. Here's the definition for a frequency distribution table, and this is exactly what we constructed from the data sets when we made our histograms in the previous video. And the only thing we're going to add to it today is a column that is for the cumulative relative frequency. This is actually a frequency table also. It just gives the name of a president and the name and their age when they were inaugurated into the presidential office. And so we're going to take this information and find the relative frequency, the cumulative frequency, and the cumulative relative frequency. And we've already found the relative frequency in the previous video. So we're just really adding a step to it. And now the steps to make this cumulative frequency table and then graph are the same as when we were going to make our histogram. First, we need the range of the ages of the presidents, and the oldest president was 69 when he was inaugurated. The youngest was 42. So now when we subtract those, we get a range of 27. The next thing we need to do is determine our class, the number of classes that we have, and also the width of each class. Now remember, as we discussed yesterday, when we're deciding on the number of classes, it's a good rule of thumb to use the square root of the number of data you have. And there are 43 presidents listed, so I'm going to take the square root of 43, and that gives me 6.5. And you can either round this up or round this down. Normally it's rounded up, but today I'm going to round it down and use 6 classes, and that's completely up to you, however many classes you want. You want to be around the same number as other people that are making the same graph. You wouldn't want to have, say, 15 classes, but it doesn't have to be exactly the same as someone else as long as it's in the same vicinity. So we're going to have 6 classes, and now to determine the width of the class, we're going to do the range of 27 divided by 6. And when I do 27 divided by 6, I get 4.5. So I'm going to make my width of each class 5. So for instance, the first class, let's say age in between, will begin at, since 42 was the least, I'm going to start at 40, and it's going to end at 44. The class following that would start at 45, and it would be all the ages from 45 to 49. Now notice that the class width is 5, and you may be confused because from 40 to 44 that gives you 4, but keep in mind 40 to 45 is how you get your width. That's what the class size comes in. And so now we're going to go to the next page and construct our frequency distribution table. and go from there. Before we construct our table, I just want to remind you of a few definitions that we learned in the previous video. This first one, frequency, remember that's just the count, the number of times it occurs within each class. So if my class is the ages from 40 to 44, I would count how many ages fall into that range. The relative frequency, remember you take that count and turn it into a percentage by doing these instructions here. The cumulative frequency is where we add the counts in the frequency column for the current class and then to all classes before it. And this, you'll see how this goes when we do an example. And then the cumulative relative frequency just takes this and turns it into a percentage, much like when you change this frequency into a percentage here. Okay, so here is our frequency distribution table. And looking back at the fifth slide that has our data on it, the name of the president and the age, we're going to start constructing this table. So my first class, as we discussed, is going to be from 40 to 44. And within that range of ages, I have 2 presidents. The next class is from 45 to 49. And within that range, I have 6 presidents. And remember, from 40 to 45 is the 5, and that's our class width. And the next class is from 50 to 54. And within that range you have 13 presidents. The next class is 55 to 59. Within that class there are 12 presidents. Following that we have a class of 60 to 64. And that is 7 presidents. The final class is 65 to 69, and we have 3 presidents in that class, giving us a total. When you add all these up, you should get the total number of data you have, and that's 43. And we do. Now the next column, the relative frequency, is just changing the frequency that we have in this column into a percentage over here. So to do that, if we take the frequency, which is 2, and divide by the total number of data we have, which would be the total number of presidents, 2 over 43, and then remember to make it to a percentage you have to multiply by 100, and we get 4.7%. Whoops. 4.7%. I'm running out of room on my little graph. The next one we would do 6 over 43 times 100, and that gives us 14%. The next is 13 out of 43 times 100, which gives us 30.2%, and I'm going to stop writing the percent sign just because I'm out of room. The following class, you do 12 over 43 times 100, and that gives us 27.9%. And then we have 7 out of 43 times 100, which gives you 16.3%. And then the last class, we have 3 out of 43 times 100, which equals 7%. Alright, the next column is our new thing for today, the cumulative frequency. And to do that one, in your first class, your frequency will always be the same as it was to begin with. So we have a 2 frequency there. For the following class, you're going to add that class to the one above it. So 6 plus 2, that would be 8. And then the following class, you would take the 13 plus the 6, which is 19, plus the 2, which is 21. After that, you would take 12 plus 13 plus 6 plus 2, which gives us 33. Following that, you add up the 7, 12, 13, 6, and 2, and that gives us 40. And the last one is you add up all the frequencies, and that gives us 43, which, remember, is the number of data sets that we have, so it should be 43. Alright, so now for the last column, relative cumulative frequency, you're just going to take the cumulative frequency in this column and make it into a percent for this column. So the first one is 2 over 43 times 100, which is 4.7%. Following that, we're going to have 8 over 43 times 100, which is 18.6%. Next, we have 21 out of 43 times 100, which is 48.8%. 33 out of 43 times 100, which gives us 76.7%. 40 out of 43 times 100, which gives us 93%. And then finally 43 out of 43, which gives us 100%. Now the next slide gives us all this information without my bad handwriting on it. Now here's all that information that we have just discovered through our mathematical applications and written all nice and neat for us. And from this information we're going to create a cumulative relative frequency graph. Okay, here we have a cumulative relative frequency graph. These are better known as an ogive. Now I know this looks like ogive, but it is pronounced ogive. The word ogive is basically a term they use in architecture to describe curves or curved shapes. An ogive is a graph that represents the cumulative frequencies of the classes in a frequency distribution. So this graph represents the last column of the chart that we made, and it shows the data below or above a particular value. So it shows the percentiles. Now, it is customary for an ogive to start at the lowest class value with a height of 0. And so in our particular case, our lowest value was 40 in our classes, and we always start with a height of 0. Now after that, you plot a point that corresponds to the cumulative relative frequency of each class at the smallest value of the next class. So what that means is, for example, the cumulative relative frequency for our class 40 to 44, that was the first class, was 4.7%. So we plot that 4.7 at the 45 mark on our horizontal axis. This means that 4.7% of presidents were inaugurated before they were 45 years old. If I was looking at this value, at the 70-year mark, it's at 100%. So what that means is that 100% of U.S. presidents were inaugurated before they reached age 70. So now using this ogive, we can answer this question: was Bill Clinton a young president in comparison to all the presidents that have been inaugurated? Say, okay, so we know that President Clinton was 46 when he was inaugurated. That's from our table of data that we began with. So according to this ogive, it shows that at age 46. That places him at about the 10% mark on the cumulative relative frequency. Therefore, President Clinton was younger than about 90% of all the U.S. presidents based on his inauguration age. It also means that he was only older than about 10% of U.S. presidents inaugurated. So what else can we learn from our Ogive? Well, we know that the graph at first grows very gradually. And so what that means is this gradual growth is that few presidents were inaugurated when they were in their 40s, from age 40 to 50. And then when we hit 50, we kind of really increase rapidly until we get to about 60. So that means that most presidents were between 50 and 60 years old when they were inaugurated. And then after that, from 60 to 70, it kind of starts fading off again. So we know that that growth slowed down at age 60. So what we will do tomorrow in class is find the distribution of the height of all the students in our AP Statistics classes this year. And we will make an Ogive and then see where people fall in comparison to all the others. See you tomorrow in class.